Hi, welcome to Technical and Engineering Academy. This is Blessed Elvis. Okay, so we are going to do the integration by substitution method today. This method can be used where you are given mostly algebra equations. That's why in some books it is referred to as integration by algebraic substitution method because it must deals with algebra. Now, the kind of algebra that deals with is where you have the fraction, the root, and of course even the trigonometric equations of different kinds, where you have more than one function as the angle. So we are going to look at different kinds of questions which will make you understand where exactly you apply the integration method by substitution method. Okay, so let's look at examples. So the examples of equations where you can apply the substitution method is where you have, let's say you have a function in the root, let's say in this case 3x minus 1. Now the only method you can use for you to integrate this expression with respect to dx is by substitution method, where you let this algebraic expression which is in here equal to a certain single variable. Mostly we use u. So in this video we are going to use u. However, it's not mandatory that you only use u. You can use any other letter, but in some books u is the most recommended letter because it's the most used letter. So in this case, in our video we are going to be using u as well. So you let a certain algebraic expression equal to a certain single variable, in this case u, and then you integrate with respect to u. So after you let a given variable equal to u, you differentiate the given algebra. Now you say, so in this case you say let u equal to 3x minus 1. When you are done with this, then you differentiate this given expression and you make then dx the subject of the formula. After you do that, then you replace the given expressions here and then even here and then integrate the given expression. Okay, we are going to look at a lot of examples. So all I'm saying is this method is applied where you have an algebraic expression in form of the root. It cannot be only square root, third root, fourth root, or any other root you might be given. So in this case, I'm going to use the square root as the example. So you might have this one, or you might have a fraction. Let's say you are given a fraction. Let's say 1 over, let's say 5x plus 1. Okay, plus 1. You might even also have an algebraic expression in form of trigonometry. Let's say you are given cos of what? Let's say 8x plus 2. So you cannot directly integrate these algebraic expressions. So the only way you can integrate them is by letting the given algebraic expression in form of a single variable. You can even have the power. Let's say where you have e power 8x minus 3, okay, dx. In this case, you cannot directly integrate this. So we are going to look at different examples. Let's say even here you have 2. Okay, let's now directly go into examples. Let's say you have been asked to integrate. So our first example is where you have the root of 40 minus 1 with respect to what? With respect to dt. So in this case, our first step is to let this algebraic expression equal to a single variable. So in this case, we are going to say let u equal to 40 minus 1. After you are done with this part, then you differentiate the given expression. So let's do that. So in this case, we are going to have du over dt because we are differentiating with respect to t. So in this case, what is the differentiation of 40? So according to power rule, here we have power of 1 at the t part. So when we multiply 1 with 4, we are going to have 4. So in this case, it's going to be 4. And then when we subtract 1 from the same, we're going to have 0. So in this case, the differentiation of 40 is just 4. So after we are done with differentiating like we have done here, you make dt the subject of the formula, because in this case, since we have replaced this algebraic expression with u, it means even integrating this should be respect with what? To u. So let's make dt the subject of the formula. So remember, we have what? We have du over dt equal to 4. So let's make dt the subject of the formula. So we can do the cross multiplication here. We know we are going to have 4. We are going to have 4 dt equal to du. When we multiply 1 with du, we are going to have du. When we multiply dt with 4, we are going to have 4 dt. So in this case, let's divide 4 to both sides. So we divide 4 there, here and there. So in this case, then we have our dt equal to du over 4. So remember, our expression was the root of 40 minus 1 dt. But we had said where there is 40 minus 1, we say let there be u. And where there is dt, since we have made it the subject of the formula here, it means where there is dt, we are going to replace with du over 4. So in this case, we are going to have du over 4. So let's just create space here. So we have the integral of u, then here we have du over 4. So in this case, where we have that, we know this is the same as saying integral of root of 4. This is the same as 1 over 4 multiplied by du, because 1 multiplied by du, it's still du. So this is just the same as this. So in this case, when we are integrating according to the rules, you take this in front of the integral. So we are going to have 1 over 4 with the integral of root of u du. So now we can easily integrate this expression that we have here. So in this case, then, let's rewrite this. We know that the square root is the same as power 1 over 2. So in this case, we are going to have 1 over 4. Then integral of u raised to power 1 over 2. This is the same as the root. When you have the third root, it's 1 over 3. When you have the fourth root, it's 1 over 4. When you have the fifth root, it's 1 over 5. So whatever root you have here is the denominator. So square is 2. So that's why we have the denominator of 2. Okay, cube is 3. So we have 1 over 3. So in this case, then, we are just going to have 1 over 2 since we have the square root. So this will be our expression. So according to integration power rule, we have to add 1 to the power and then divide the same power. So let's do that. So in this case, we have 1 over 4 u power 1 over 2. So we add 1 to the power over the same 1 over 2 plus 1, then du. So let's further integrate this. So here we have 1 over 4. So in this case, we are going to have what? When we add 1 to the half, what are we going to have? So we are going to have 3 over 2. So in this case, it's going to be u 3 over 2 over 3 over 2. Then plus the constant c. So whenever you integrate an expression given, you have to include the constant c. So in this case, then, this is the same as 1 over 4 rather, divided by what? 3 over 2. Remember, on top there we have what? 3 over 2 plus constant c. Okay, c. So in this case, this is the same as 1 over 4. According to division rule, when you are dividing the fractions, you simply change the sign here to multiplication and interchange the numerator with the denominator on the right side. So you are going to have 2 over 3. Okay, u power what? 3 over 2 plus the constant c. So let's create space on top here. Okay, hopefully you are following. However, if you are not, why not? We are going to do a few more examples so that you get the concept. Okay. So in this case, then, when we multiply 1, so 1 multiplied by 2, we are going to have 2, over 4 multiplied by 3, we are going to have 12. So u power 3, okay, the other 3 over 2 as the power of u plus the constant c. So in this case, we can simplify this. 2 into 12, it's 6. So we have 1 over 6, then u power 3 over 2, then plus the constant c. Now, if you remember, we said let u equal to what? Equal to 40 minus 1. So where there is u, we are going to replace with this, because this is our original equation. We had just borrowed u so that we can easily answer this expression. So in this case, we are going to get back our 40 minus 1. So where there is u, we are going to replace with 40 minus 1. So in this case, then, it's going to be 1 over 6, then 40 minus 1 power 3 over 2 plus the constant c. So this is our solution. So that's how we do it. So let's look at another example. Let's say where you have been given 4 over 5x minus 3 with respect to x. So to answer this question, we have to let this algebraic expression here on the denominator part we have to let it to a single variable. So in this case, let's use u, since we are using u in this video. So it's going to be let u equal to 5x minus 3. After we are done with this, we do what? We differentiate. So let's differentiate. So in this case, we are going to have du over dx, okay, equal to, what is the differentiation of 5x? So x there has 1. So when we multiply 1 with the base 5, we are going to have 5. And then when you subtract 1 from x, we are going to have 0. So x power 0 is just 1. Okay, and then the differentiation of a constant number is just 0, so we are just going to ignore 3. So we have this as our differentiated expression. So in this case, let's make dx the subject of the formula. So we know the way we can do that is by cross multiplying here. So when you multiply dx with 5, you are going to have 5 dx equal to 1 multiplied by du, we are going to have du. So let's make dx the subject of the formula so that we can replace. So this and that. So we are going to have, in this case, dx equal to what? Equal to du over 5. So where there is dx, we are going to replace with du over 5. Where there is 5x minus 3, we are going to replace with what? With u. So let's do that. So in this case, then, we are going to have 4 over u. Then where there is dx, we have du over 5. Okay, so this is our expression. So in this case, we know that when we multiply here, okay, let me just do this. So we have 4 over u. This is the same as 1 over 5, then du, because 1 multiplied by du, it's just du. So it doesn't make any difference here. So when we multiply 4 by 1, we are going to have 4 over, then 5 multiplied by u, we're going to have 5u here, and then we have du. So in this case, then, we know that we can factorize 4 over 5. We write it in front of the integral, because whenever you have a fraction or a constant number and then you are integrating, you always write it in front of the integral. So we have this, and then here we remain with 1 over u. We are integrating this with respect to du. So now, after you are done with this, we know that the integration of any fraction where you have 1 over a certain variable, a variable which has a power of 1, take note of that. The denominator should have a variable with power of 1. So in this case, we have 1 over u. When you are integrating such a fraction, it's always ln of the variable that is present. So in this case, it's u, so it's ln u. If you had, let's say, 1 over x, if you are to integrate this, it is what? Ln of x. So here, you write the variable which is present in the expression. So make sure that you take note of that. So at the end of this video, I am going to write different, or rather I'm going to give out different integrals where you have different kinds of equations and how you can integrate them. Okay, so I will do that. Now, so having said that, in this case, then we are going to have 4 over 5. So what will be the integration of 1 over u? It's ln of what variable is present is u, so it's ln of u. Okay, and then plus the constant c. Now remember, our u was what? Our u was 5x minus 3. So we are going to replace where there is u with 5x minus 3. So in this case, then we are going to have 4 over 5 ln, where there is u, it's 5x minus 3, and then plus the constant c. So this is our answer. This is our final answer. Okay, let's look at this. How can you do this one? Where you have cos of 7 theta, then plus 5, with respect to what? Theta here. So in this case, this is an algebraic expression. So we are going to say, let u equal to 7 theta plus 5. By now, I know you have gotten the concept, so you may go ahead of me and try this one. So let's differentiate this according to the rules. So we differentiate this du over d theta equal to, when we differentiate 7 theta, of course, we're just going to have 7. So let's make d theta here the subject of the formula. So when we multiply this, we are going to have 7 d theta equal to du. So let's make d theta the subject by dividing 7 to both sides. So this and that cancel. We are just ending with what? D theta equal to du over 7. So in this case then, where there is d theta, we are going to replace with du over 7. Then where there is 7 theta plus 5, we are going to replace with u. So let's do that. So in this case, we are going to have cos of u, and then we are going to have du over what? Over 7. Now, when we have this, of course, we know by now that this is the same as cos 1, or rather cos u first, then here it's the same as 1 over 7, then du. So since 1 over 7 is constant, we are going to take it in front of the integral. So we are going to have 1 over 7, and then integral of cos u, then du. So what is the integral of cos? The integral of cos is simply the sign. So like I said before, I will give out the different formulas where we integrate different kinds of given expressions. So that includes the trigonometric functions as well. So in this case then, we're going to have 1 over 7. So always the integral of cos gives sine. So it's sine u plus the constant c. Now remember, where there is u, we had said let u equals to what? 7 theta plus 5. So we are going to replace with that. So in this case then, we are going to have 1 over 7 sine of, where there is u, we are going to write 7 theta plus 5. Okay, and then here we add the constant c. So that's it for this equation. Now, what about this one where you have, let's say, you have been given x squared, and then here we have sine, and then here we have x power 3 dx. Which one do you think we can let u equal to? Okay, you are right. So you let this one, which is in here, equal to u. You don't let this one. You let this one, which is in here, because this is the complicated algebraic expression as acting as the angle. So there's no way we can integrate this apart from using the substitution method. So let's do that. So let's say let u equal to x power 3, and then let's differentiate this. We are going to have du over dx equal to what? So when we are differentiating this, we are going to write this in front. We are going to have 3. Then we subtract power with 1. We are going to have 2. So let's make now dx the subject of the formula. We are going to cross multiply here. So we are going to have 3x squared dx equal to what? Du. So when we have this, let's divide 3x squared to both sides. So remember, we have 3x squared dx equal to du. So let's divide 3x squared to both sides, even here 3x squared. So we are going to remain with dx here equal to what? 1 over 3x squared then du. Because 1 multiplied by du, it's simply du. So even if we write it like that, it's just okay. So now remember, we had said let u equal to what? Equal to 3 power 3. Rather x power 3. So in our expression where there is x power 3, we are going to replace with u. And where there is dx, we are going to replace with this that we have here. So in this case then, our integral will be, so make sure that you are writing somewhere because you might be confused. So this is the expression that we had at first. So let's replace now. So in this case, we are going to have x squared, then sine of what? U, multiplied by what? 1 over 3x squared du here. Okay, so in this case, as we can see, this squared and that squared can be cancelled. So in this case, we are remaining with what? We are remaining with sine u multiplied by, here we are just remaining with 1 over 3 du. So this is a constant, so it can just come in front. So in this case, then we are going to have 1 over 3 outside the integral. So we have here the sine of u and then du. So what is the sine of u? When you are integrating sine, you get what? Negative cosine. Okay, it's opposite. When you are differentiating cos, we have negative sine. But when you are integrating cos, when you are differentiating cos, you have negative sine. But when you are integrating cos, you have sine. Okay, when you are integrating sine, you have negative cos. But when you are differentiating sine, you have cos. So make sure you take note of those two differences that's there. So in this case, let's replace where there is, or rather let's integrate. So we have 1 over 3. Then when we integrate sine, we are going to have what? Negative. So we can just write it in front. So negative 1 over 3. And then this is going to change into cos. So where there is u, we had what? X power 3 plus the constant c. So this is the answer that we have. Okay, so we can keep on going just like that. So let's do 1 for the power. What about where you have, let's say you have been given 4 and e raised to power 8 x minus 1. So we are integrating this with respect to the x. How can we go about this one? So you let the given algebraic expression in the integral to u. So the algebraic expression you have here is what? Is 8x minus 1. So let's say u equal to 8x minus 1. So in this case then, let's differentiate this. So we are going to have du over dx equal to, what is the differentiation of 8x? Okay, of course it's 8. So we cross multiply. So this case then we are going to have 8 dx equal to du. Then we divide 8 to both sides. Even here we divide 8. We know that we cancel this and that. So in this case then, we are remaining with dx equal to du over 8. Okay, so where there is dx here, we are going to replace with du over 8. And where there is this algebraic here, we are going to replace with u. So let's do that. So in this case, then we are going to have 4e. So we are going to have u here, and then here we are going to have 1 over 8 du, because 1 multiplied by du, it's just du. Remember, we had du over 8, so it's just the same thing. So even if you have 1 over 8 du, it's just the same as du over 8. So in this case, we know that we can simplify this, so let's do that. So we have the integral of 4 into 8, it's 2. So in this case, then we are going to have e raised to power u, and then here we are going to remain with 1 over 2. Remember, we are integrating this with respect to du. Okay, so in this case, then let's take this in front, 1 over 2, the constant we have. So we are going to remain here with e du, e power u du. Now, what is the integration of e power u? So in this case, we are going to have 1 over 2. So according to this, you write this same function divided by the differentiated function of the power. So when we differentiate the power, we are going to have only 1 as the denominator. So when we divide 1 into e power u, it's just e power u. So we have that, then plus the constant what? C. So where there is u, remember there is what? There is a certain algebraic expression. So we are going to replace, where there is u, we had 8x minus 1. Okay, then plus the constant c. So this is our expression for the given question. Okay, so let's do one last example. This one will be based on definite integrals. So whatever we have been doing is indefinite. So in this case, we are going to do definite integrals. So let's say you have been given a definite integral where you have, here we have 4, and then here we have, let's say 0. And then in his root, you have been given another 2x plus 1, then dx. So in this case, we firstly integrate before we replace with these limits here. So let's integrate this. So at the moment, you have to ignore these. Okay, so we are going to have, let u go to 2x plus 1. Then we differentiate this expression. Okay, of course, by now, you know, we are just going to have 2, and then we cross multiply. So this multiplied by that, we are going to have 2 dx, and then 1 multiplied by du, we are going to have du. Then we divide 2 to both sides. Of course, we are going to have dx equated to du over 2. So in this expression, where you have dx, we are going to replace with du over 2, and where we have this, we are going to replace with what? U. So in this case, we are going to have the integral of the limits 4 and 0, and then the root of u. Where there is that, we have 1 over 2 of du. So let's take this to the front. So we're going to have 1 over 2, and then here we have 4, and then 0 root of what? Du, then du. So let's integrate this now. So remember, we have this limits 4 here and 0, integral of u, then du. Now we know that the square root now is the same as the given variable raised to power what? Half. So it's u power half, then du. So according to the integral rules, you add 1 to the power, and then you divide the same power. So in this case, we are going to have u 1 over 2 plus 1 over 1 over 2 plus 1. Okay, so when you have indefinite integrals, you don't add the constant c. Okay, so in this case, we are just going to have this, and the limits that we have are what? 4 and 0. So in this case, we are going to have 1 over 2. Now, what is half plus 1? So half plus 1 is 3. It's 3 over 2. So even here, we are going to have 3 over 2. Okay, remember the limits we have are 4 and 0 here. So in this case then, we are going to have 1 over 2. So this is the same, so we are dividing this on top here. So it's the same as we are dividing 3 over 2. Or let me just write this properly. 3 over 2, and this is division. Okay, then here we have u. Let me just wrap the top part here. Okay, hopefully you are following. Okay, so we have u raised to power 3 over 2. Okay, remember the limits that we have are at 4 and 0 here. Okay, so this, in this case then, so we are just simplifying this expression here so that when it comes to replacing, we won't have problems. So we have 1 over 2. So when we are dividing here, of course, we can just interchange the sign, and then we change the denominator to numerator and the numerator to denominator on the right fraction here. Okay, so in this case, then here we have u, then 3 over what? Over 2. Remember, our limits are 4 and 0. So in this case, this 2 and that 2 can cancel. So in this case, we have what? 1 over 3. So in this case, we have 1 over 3. Okay, I'm just writing it here. So 1 over 3. Then we have u raised to power 3. 3 over 2. And then the limits that we have are at 4 and 0 here. Now remember, we have just gotten this u in replacement of the algebraic expression that we had at first. So in this case, then we have to get back our algebraic expression. Remember, our u was 2x plus 1. So we are going to get back our algebraic expression. So where there is u, we are going to replace with 2x plus 1. So in this case, we are going to have 1 over 3, and then we have 2x plus 1. Okay, raised to 3 over 2. And then the limits we have are at 4 and 0. Now we have integrated the given expression. The next part is now replacing these limits that we have. So you replace with the upper limit, and then you subtract, replace with the lower limit. So let's do that. So in this case then, where there is x, we are going to replace with 4. Then we subtract again, we replace with the 0 as the lower limit. So let's do that. So in this case, we have 1 over 3. Okay, so I will replace firstly where there is x with what? With 4. So we are going to have 2, 4 here, then plus 1. Okay, and then minus, this case, this time I will replace where there is x with a 0. Okay, like that. So here we have 1. Okay, we have that. So let's now simplify the given expression. 2 multiplied by 4, it's 8. 8 plus 1, it's 9. So we are going to have 1 over 3 multiplied by 9. Okay, then we subtract 1 over 3. 2 multiplied by 0, it's 0. 0 plus 1, it's just 1. Then we are going to have here 1 over 3 multiplied by what? 1. So let's simplify this. We know that 3 into 9 is what? Is 3 minus 1 over 3. So we have a fraction of 3 minus 1 over 3. We know that this has a denominator of 1. Whatever number, or rather letter, anything that doesn't have a denominator, it means there is a denominator of 1, because denominator of 1 is just simply the given expression. So 3 divided by 1 is just 3. So in this case, we can find the common denominator. We know 1 multiplied by 3, it's simply 3. So 1 into 3, it's 3. Then 3 multiplied by the numerator, 3, it's 9. So 9 here minus 3 into 3, it's 1. Then 1 multiplied by the numerator 1 here, we are going to have 1. So in this case, then we are going to have what? 8 over 3. 9 minus 1, it's 8 over 3. So if we want, we can simplify this. How many times that does 3 go into 8? Okay, it goes twice. Remainder 2 over 3. So this is our answer. Okay, so like I said earlier, so you can simply pause the video and copy these general antiderivatives of different kinds of expressions. Thanks once again guys for staying this far. Please like, subscribe, share and turn on the notification button so that you are updated whenever I upload a new video. Stay blessed.